Hi everyone. So my name is David. I'm a statistician working at INRAE in France. And so I'll be presenting the SCATE project, which aims to develop a scalable institutional system for managing and hosting and deploying Shiny apps to the web. So INRAE is the French National Research Institute for Agriculture, Food, and the Environment. We are around 12,000 researchers and engineers all over France and in French overseas territories. And I'm based in Bordeaux, in southwest of France. And so in our institute, Shiny is very popular because it's such a powerful tool to simulate, map, visualize, and share research while being accessible for non-IT people, such as statisticians and biologists that only know how to code in R. So it's a very convenient way for them. The SCATE team is a bunch of 15 engineers coming from all over France, working on Shiny apps deployment. And so SCATE actually comes from Shiny Kubernetes service, which was reduced to Skate, like the skateboard. So the main problem that we had in our institute was that Shiny makes it so easy to develop beautiful web apps and interactive graphs. But we always had the problem that these apps usually work perfectly fine on our own computer. But we had some problems when we needed to share them with colleagues or with the web. In our case, paid solutions such as POSIT, Amazon, Google are not an option because we are not allowed to use public money to pay for them. And we are in the European Union, so because of GDPR, we can't use these kind of services. And again, statisticians and biologists are not IT guys. So even the open source solutions were not an option because they usually don't know how to use even Linux sometimes. So we had to find another way, which is the SCATE project. So this is the main SCATE workflow. So it relies on a GitLab instance in green and on an OpenStack with Kubernetes installed in pink. All of this managed by the SCATE team with the help of our IT department. So first we have on the left the Shiny developer with the Shiny app, which pushes the code to a repo, which is actually a fork of a template that we made. And this push triggers an automated CI/CD pipeline here in light green. This pipeline first uses renv and pack to identify our package dependencies and system libraries, to make a Docker file, then making a Docker image, a Docker container, which is uploaded to a registry. And then final step, Kubernetes, which is like a container orchestrator, deploys the app in a secure and scalable way. So to the web, to myapp.skate.inrae.fr. So that's the big picture. Under the hood, we are using a package that we've made, which is Skate Tools. So first, this package will try to find the Docker file. Sometimes some users already have their Docker file ready, so we can just use it. And if not, we'll be looking for good programming or programming practices. So is there a renv.log file? If not, we will try to make one. Out of this to find, again, our package and system libraries. Out of this to, in the end, build the Docker file, Docker image, which is then used by Kubernetes. And so this whole workflow works for apps that have packages coming either from CRAN, from Bioconductor, and from GitHub. So this is the CI/CD. So it may seem very complex, but from the user point of view, it's quite simple. All you need is some basic Git knowledge. So you just need to push your code, and you have this pipeline that appears with all the green steps that are automatic. And then all you need to do is to hit the deploy button here that will deploy the app to the web and also upload the app to a Shiny proxy catalog, which displays all the apps that are published through our service. And there are quite a few of them, those apps. So the project started in mid-2022. Then we had the kickflip version in 2023. And we are now almost at 100 applications developed, published through our service. The next version is Oli version. And now you have 20 seconds to scan this QR code if you want to learn more about this project. Or you can also reach me by email or during this conference. I also have some business cards, I think. That's all for me. Thank you.
Hi, welcome to my lightning talk. It's using Google Lighthouse to analyze Shiny applications. My name is Osheen Macoscar, and I'm a data scientist who works for Jump Rivers, and I have done for the past 2 years. I work mainly with Shiny on our packages. So if you haven't heard of Google Lighthouse before, what is it? It's a tool made by, as you can probably guess, Google. It's open source. It's built for analysing web pages, but we can also use it to analyse our own Shiny app. So this can be local apps or hosted apps. All you need to pass to Google Lighthouse is the URL. So, spoiler alert, it's not a magic trick. It's not going to speed up any slow database calls or any inefficient Shiny apps. But what can be used for is assessing the Shiny app to make small gains and benchmarking for future development. So an example Lighthouse report should look something like this, where we've got a few scores and then an overall performance score. You can use the terminal to obtain JSON or CSV, which is what I've done, but generally like a visual representation of a Lighthouse report is that. So how to actually use Google Lighthouse. So you can use it in the Chrome DevTools. So go to DevTools, then More Tools, and then Developer Tools, and then you can go to the chevrons and then select Lighthouse, and it should look something like this, where you'll have a button that says Analyze Page Load. In the terminal, it's a little bit different. You'll need to install Lighthouse if you don't already have it installed using npm. And then what we need to pass to Lighthouse is the output format, the output path, and then the URL of the app or web page you'd like to test. And then you can also add a preset desktop because the default is mobile. So understanding your Lighthouse reports a little bit more. I know when I first saw all these metrics, I was like, what on earth do any of these mean? So the first one we've got is first contentful paint, and this is basically the first thing that appears for users of the app or web page. Speed index is just the speed it takes to load. Largest contentful paint is the largest kind of piece of content on the app or page. Total blocking time is to do with the interactivity, and then cumulative layout shift is how much the website or app shifts around whilst it's loading. You've got the weight in there as well. Oh, we've passed that slide now, if you didn't see that. So this is a bit of a segue. So I want to mass test some Shiny apps. So a colleague pointed me towards the 2021 Absalon Shiny App Contest because there was lots of Shiny apps that I could test. So I had to go through all the links, see which ones still worked, and then run a test on all of these. So this is what my data looked like, just overall, all of the metrics that I mentioned before. So this is pretty expected. So there's a few apps that are performing quite well, and then it kind of tails off as you get to the more like slower apps. So according to the Lighthouse docs, 40 of the 134 apps I measured had good performance. Most of them, as you'd expect, had it needed some improvement. So 74 of them had all right scores, and then a few with poor. The average was 73. So a few issues that I found was the contentful paint metrics weren't always fully tracking the widgets. So for example, in a Plotly plot, the frame might have loaded, but not the actual Plotly. So that would give some kind of misleading scores on those metrics. And then this is another segue. So I wanted to test the impact of widgets on Shiny apps. So I started with the Shiny, one example, Hello app. David's already shown this, I think, on the screen as well. But I iteratively added more complexity to the apps. So the first thing I did was change the plot to a Plotly. Then I added a data table. Then I changed that to a DT interactive table. And then I added a date input just to see what that did, then a Plotly app in the sidebar as well. So each time I'm adding more complexity to the app, and then I tested each app 10 times, and then looked at the different Lighthouse metrics to see what was changing based on the changes I made to the app. So here's 2 plots. You can basically see on the left one that as the apps are getting more complex, the speed index is increasing and the time to interactive is also increasing. I noticed, however, in this plot that some of the more complex apps were going from left to right as the dots for complexity. Then there was a few apps that were getting different scores on different runs of the Lighthouse report. And I thought that was quite strange. So I've made a radar plot looking, and that looks horrible. And sorry, Cara. But yeah, I've got a hand now. So the sub-90 scores were actually doing worse on all metrics. And the plot on the right was to show the fetch time. So I think the issue is actually to do with my internet for the period of time that I was running those apps. And this is actually the last slide, so I've got a little bit longer. This is probably cheating. But yeah, the final words are, Lighthouse is a great tool to assess your apps, but you can take it with a pinch of salt because there is a few issues. Like I've said, HTML widgets are going to slow down your Shiny apps, but I think they're what makes Shiny apps useful and fun, so I probably wouldn't recommend not putting them in for like small, like 1 second impact on your app. And I think that's it. So that's my email, Osheen at Jump Rivers. I do actually work for Jump Rivers. I've got the t-shirt on. And yeah, my GitHub as well. So thank you.
Thanks everybody for coming to the Squid Games of conferences. I'll be talking about our risk assessment as a service, specifically more about the project rollout than specific technical details. Yeah, I think Pedro gave a lot of spoilers. Where is he? He's not here. Okay. So a little bit about me before I get into this. I was a molecular biology PhD in a former life, but currently I work at Jumping Rivers as a data scientist. I'm involved in implementation consulting, DevOps, sysadmin training, and in the context of this talk, design and delivery of our risk assessment services. So risk assessment as a service. So some industries require regulatory compliance of their environments, like Pedro was saying earlier. The thing is that there are different regulatory requirements for different industries, and this is quite nuanced and requires both domain knowledge and collaboration between ourselves and these companies and these industries. So in the context of our packages, does a package do what it says it does? Is the package fit for purpose? Does it do what I need it to do? Is it secure and is it well maintained? And risk appetite in these areas varies widely between industries, between individual companies, between individuals. So on the left here, we have the Wild West, where we have a very high risk appetite. We have students and rogue devs, and on the other side of the spectrum, we have the validated environments, where we care a lot about these parameters. And sort of somewhere in the middle, we have these vaguely sensible people who want to prove that their environments are safe-ish. So in the Wild West, we just care that maybe this package is going to not threaten my system, but it's okay. Whereas in the validated side of things, we want to make sure that there are custom test cases potentially that are actually used between builds of your environment, for example. So a lot more stringent. Okay, so in the before times, validation was sold as a product, so this predetermined set of packages, and this was manual and time-consuming and expensive, especially if you had packages that you wanted to use that were not within that range of packages that you were allowed to use. And our approach is more about validation as a service, so working with our clients rather than for them, developing with them rather than for them, and automating everything that we possibly can. And importantly, in lockstep with efforts from the R Validation Hub. So taking the most strict requirements and making them accessible to the whole spectrum. The R Validation Hub is the teacher at the school dance who's getting the awkward teenagers to actually dance. And so they all need to work in these validated environments, and they have slightly different processes. And the validation hub is concerned with reaching consensus about how to approach risk and mitigate it. And they already have some tooling available. So they have this risk metric package, a Shiny app, and a package collection that they're busy working on. And so this is really the foundation for what our work is about, is sort of improving on these already existing tools and leveraging the tools where we can. Cool. So if all of these cool things exist, why are we actually getting involved? So there's some limitations in these open source tools, and we feel like it's more efficient to service our clients with the tools that we maintain, so we don't have to submit an issue on open source repos and hope that it gets fixed. We're also commissioned to contribute to open source. So how this works is that you'll give us your package and its dependencies, the version. We'll perform an automated assessment, generate this automated report, like Pedro showed, and then decide if the package is good enough, we'll include it in the regulated environment. If the answer to is package good enough is no, and this criteria differs, like I said, between companies, we'll do some manual remediation. So we'll write some extra test cases. We call them test patches. Or we'll improve the documentation for the package, that kind of thing. So make it usable for you as the consumer of that package. So this is where we are currently in our rollout. So we've worked on the assessment R package. So we've created that and tested it. We're busy getting client feedback, and we're about to start using it in production. So that's pretty exciting. Same for the reporting package. For the plumbing, so sort of the databases and the backends and servers where we're actually going to run this code, we're still busy working on that. And for remediation, we have the ability to create these test patches for packages. And the next thing that we're going to do is actually remediate some client packages. So we've never done remediation in the wild, so it'll be really good to actually do that for the first time. So Pedro showed you our proof of concept Shiny app. The idea is to basically design and develop these specifically for clients or create an open source version. And then the open sourcing component, we're busy talking to our stakeholders within the pharma industry to kind of come up with what we want to open source and when and how. So our sort of happy path timeline currently looks like this. By the end of this year, we'll have our first production release. We'll be onboarding clients next year, additional clients other than the ones we're currently working with. And then we'll do some public release of open source components. So thank you. We're still looking for a name for our framework. We have some ideas, but it would be really cool to crowdsource some ideas if you have a cute name for our new product. Yeah, please pop it in at the link. It would be really good to get some input there. Thanks.
So hi everyone, my name is Juan Vallarta. I'm a data scientist at FINE. FINE is a Swiss NGO that is focused on facilitating access to medical diagnosis. And today I'm presenting this Shiny app, which goal is to support the diagnosis of Chagas disease, which is a disease that is only diagnosed in 10% of the cases. And this is kind of the distribution of the disease. It's mostly endemic in Latin America, but because this lack of diagnosis has been spread to other countries in the world. And of course, it's having a huge impact in the healthcare costs in the healthcare systems in different countries. So because of this, there are different testing diagnoses or approaches. Some are cheap, but they require more visits to medical settings. And there are others that are more expensive, but they require less visit to the medical settings to be diagnosed. And as you can imagine, this implies some challenges from a logistic and financial perspective, because not always the cheapest testing approach will be the best, depending on the condition of the population. And also this complicates the early diagnosis of the disease, and therefore the prognosis and the spread of it. Together, FINE with other organizations like WHO and other international organizations, we were aimed to identify the best testing strategy for the Chagas disease, depending on the characteristics of the populations. And then we proposed to have this Shiny app that is an online tool that facilitates the collection of this data. So this is kind of the journey. We have the user input about the population and about also the test. And then we created an algorithm that is basically doing all the analysis of the different conditions of the test and the populations. And then, of course, we moved this into a nice and easy to use Shiny app that is using this patient pathway library that we created for this purpose. And then we also create this Shiny app as a library using Golem. And then, waiting a bit. Then this is the kind of the structure of the Shiny app. We have different modules. Some are for the user inputs. And here the most important are the scenario data and the test data, because these are dynamic. Depending on the condition and the input that the user put into the app, this model will be created dynamically, and then we pass all this information into the algorithm that we call patient pathways. And then we have 2 extra modules that are handling all the general results and also the results that are specific for each scenario. And then we have the, I'm going faster than. Then we have the kind of the structure of the patient pathways library, where we have 2 main functions that one is just taking the data from the Shiny app, and then this is transforming everything into a list, so it can be better structured for the algorithm. And then the other function that we have below are the ones that are really doing the job. So we have a function that is specifically for the algorithm, and then we have an additional function that are basically creating some tables, creating some plots, some diagrams, etc., that are just making the algorithm to look nice. And then this is kind of the general look of the app. As you can see, we have some pictures that basically I'm displaying different testing strategies with different number of visits, etc. Then we have some general inputs about the population, about the tests, etc. And as you can see below, we have the option to create different scenarios to compare different testing strategies. And this is a bit how it looks like in the Shiny app. So as you can see, we have a scenario 1 and number 2, and each one has different number of tests because the pathway of this strategy is a bit different. So this allows the user to pray a little bit about what is the best approach. And then we have the results that are also created dynamically. And you can see here that we have 3 different scenarios, and each one is displaying different information. You see that the diagram that is basically suggesting different number of visits to medical settings, and then comparing some costs. And we have some predictive and negative values that are also being compared. And of course, we also have some nice visualization. We have some plots that are useful for comparison, and a table that is basically summarizing all this data. And this can be downloaded into a report that can be shared directly in the app as an HTML format. At Fine, we plan to extend this app to other diseases, as we have done before for other Shiny apps that we have created. This app started with COVID during the pandemic, and now it has evolved into a big monster, having a lot of diseases. And one of them is monkeypox, which is also an important one at this moment. And we are also working on a data portal where we want to centralize all the Shiny apps that we have created, and where we also plan to store all the data that we have about diagnosis. But the data would not be only about at Fine, but also about other organizations like WHO or any other organization that is related to this topic. And finally, I just want to thank Ioana Manzoki, which is also a principal data scientist at Fine, and who also supported the development of this app, and to Kira, who was the person who created the algorithm for the app. Thank you. Questions?